Hello guys, welcome to another video. So in this video, we will be looking at how we can tackle SickOs. So SickOs, there are two Vulnhub machines on this release. We have already looked at how we can tackle 1.1. So for today's video, we will be looking at how we can solve 1.2. As usual, I have already done the NMap scan to save time, and this was the NMap result. So you can see it is the same NMap command as usual. We are scanning all of the TCP ports, and we are outputting it to a file called output. So this is the half sync scan, SS, and version detection. So we can see that the output is we have TCP port 22 for SSH and 80 for HTTP server. So it should be quite obvious that the initial foothold in should be via this web server. So let's take a look on our browser. Okay, so we can check out Burp to see if there's anything interesting. So nothing in here. There's a HTML comment that says nothing in here. Okay, so the image as well is loaded from this / directory. So what we can do next is we can run Nikto. It's a web server scanner, so it should be able to provide us with more information. And we can also run directory buster to check if there are any hidden files or directory that could be useful to us, because right now we don't have anything that is useful. Looking at the HTML response, if there is no further information, then we will look into web server related remote exploit. It is very unlikely, but let's see what we have here from the output. Okay, so Nikto is still running. It's giving us the header versions, which we have already observed in the burp response. So directory buster is more interesting. It is able to tell us that this web server is running PHP, and there's a test directory that is listable. So it has directory listing enabled. So let's just visit it. Okay, so there's nothing here. Let's look at burp to see if there's any hidden information. Okay, that's interesting. It seems that there are no further information as well from burp. Since there is another directory found, maybe we can run Nikto on this directory as well. It could potentially help us to obtain even more information. /test. So Nikto is able to detect that it has directory indexing, which means that all of the files in this directory will be displayed to us. Okay, so the first Nikto scan, the result is out. There's nothing interesting on the main directory. So let's just wait for this to finish. This is on the /test/ directory. Okay, so we can see that the second Nikto scan against the /test/ directory has also been completed without much results. So another way we can enumerate web servers is through the help of NMap scripts. So there are a few NMap scripts that could be quite useful to further enumerate HTTP web server. So let's take a look at what are available to us. So these are all the HTTP related NMap scripts that we can use. So some of them requires a very specific arguments, some of them do not. So let's take a look at what could be useful to us. So server status, not really. ASP, they are not using. So Okay, so file upload exploiter. File upload could be interesting since we have the test directory that has directory listing available, but we don't have any upload forms available. So there's nothing on the front end that allows us to upload something. So methods could be interesting. We haven't really looked at the available methods on the web server, so maybe we can try this. So I hope that this syntax is correct. So this shows us the supported methods over here. So it's the typical get hit post option request. So option request is very interesting. So if we use option request, it should show us what are the methods available on the web server. But in this case, it is not showing anything. So let's try it out on the /test directory. Okay, so this is interesting. So we definitely found a way in. So we can see that this is actually running WebDAV. So WebDAV is a protocol that allows the backend people to manage files on their system. It's like FTP, you can upload files and download files, delete files, that kind of stuff. So you can see that it allows all these methods, all these HTTP methods. What is interesting to us is the put method, because if this works, we will be able to directly upload a PHP file and just get reverse shell from there. So let's try and do that. So let's just make a test file with a sample PHP code that displays PHP info. So if this works, it will just execute this function and display to us the content of it. Okay, let's try and see how we can upload files using curl. Curl upload files. How do I post a file using curl? Okay, so let's try this command to see how things goes. The file that we want to upload, test.php, and we want to upload in this directory. Okay, so let's proxy it to our burp and we can investigate it from there. Right now we just need a sample upload request so that we can play with it. Okay, so this is what we have. This is from curl. So we know that we should be using put because it is allowed, and that is how you upload files via WebDAV. So this is definitely broken. So let's just fix this like this, and let's try and send it. And it's saying forbidden. Okay, so maybe we need the name of the file. Okay, created. That's great. So this means that we should have successfully uploaded test.php file. So let's check out the browser, and yes, we did. And we can see that we successfully executed PHP code over here. So that is really great for us. So what we can do next is to upload a reverse shell, and this will allow us to get a foothold into the system. So let's just grab a copy of the PHP reverse shell that we have on our Kali operating system. And let's change the IP to our listener IP, which is going to be at 132, and the typical listener port that we always use, 8443. So reverse PHP shell, PHP reverse shell. Okay, PHP reverse shell. Okay, so Let's get this request, change it to put, and this should reverse.php. Okay, so this should be fine, I guess. So let's just quickly try it out. Reverse.php. We forgot to set a listener over here. So let's just set a listener over here and let's just try and send it over. Okay, that is weird. We should definitely get a shell back. Maybe this thing is broken. Maybe the content of the file is broken. Okay, so let's just do it the copy and paste way, which is definitely going to be syntactically correct. So let's just copy the whole block of this text and copy, and let's just paste it over here. Okay, this is definitely going to be correct. Let's upload it again. This should overwrite the file. Yep, overwritten. So let's try and initiate again. And we should get a callback. Nope, we didn't get any callback. But you can see that the page is loading, right? So the reverse PHP is definitely executing, but we did not receive any callback. That is weird. Let's just upload a web shell and enumerate the system, I guess. Copy web shells, PHP, simple PHP backdoor, and then let's just upload this. So this is how you use it. You just add append cmd at the back and you can execute your command. So let's just do that. Okay, so now we can execute command via cmd equals to cat etc password. Yep. So we can execute command now, and we know that there's a John user. So which nc? So we definitely have netcat. Netcat-e. Netcat dash listening to port 8443 and execute bin bash. Okay, it's not working. Maybe /bin/. It's definitely not working. 1368443. Nope. It is not opening any port for us. So that is weird. Okay, so this is not going to work. Okay, so what can we do? Let's see what's running. Cron job is running. Okay, there's nothing interesting. Okay, so it seems that there is some firewall running that restricts outbound connection. So one way we could do this is we can try the most common allowed outbound ports. So for example, this could be so just now when we tried the PHP reverse shell on port 8443, it didn't work. So we can validate this with netcat since there is netcat available on their system. So you can see that it's unable to connect back to us on port 8443. You can see that the page is loading, but we didn't receive any callback. So the next very common outbound port would definitely be 53, because 53 is DNS. So on any systems, usually they will not restrict outbound DNS because DNS is a very important protocol that is required for systems to function normally. So let's try DNS. So let's do the netcat command again, and let's point to port 53. You can see that there's no callback as well, so port 53 is out of the picture. The next common port would be something like 80, because it's normal for a system to allow outbound port 80 to browse the websites. So let's do the netcat command again and test for it. Okay, there's no callback as well, so the next port would be port 443 is another common port for browsing web servers. 443. Okay, so we can see that 443 was successful. So there's a callback. So we know that outbound 443 is allowed on this on our target. So let's copy the PHP reverse shell, and then let's make a new copy, and we can change it to port 443, since we know that port 443 outbound is allowed on our target system. So let's just copy this, and we can create a file. We can create a new PHP reverse shell on our target. So let's create the PHP reverse shell as 1.php, and we can paste in the content, and we will see that it gets created. And let's set up our listener on 443, because that is where the reverse shell is coming in. And let's browse to our 1.php reverse shell, and there we go. We managed to get a PHP reverse shell over TCP port 443. Okay, that's great. So let's check out what we can do. Okay, so there's this annoying double letters coming up again. Okay, let's try again to get a new reverse shell so that we can fix the double letter issue. And you can see that it's working now. That's great. So let's see what we have here on the server. Okay, cron job is running, and there's nothing much of interest. So let's see netstat. Okay, netstat. Okay, so there's really nothing listening on this server at all. We can see that there is only SSH 80, and this is for DHCP. So let's navigate to John directory, which we know there's nothing on here. And the web root directory, where's the web root directory? So we know that there's nothing on the web root directory as well. So there's nothing on the server. So let's take a look at the cron job, because we know that it's running. Cron star. Okay, placeholder BSD is pretty standard. So this chkrootkit, okay, this is definitely something that is out of the norm. So this is a software. That is weird. D package list. Okay, D package list, and then we want to grab for check. Okay, so we can see that this is a rootkit detector, and is version 0.49. Okay, so I think, okay, this is definitely an outdated kernel, but during the release of this vulnerable machine, this should be the latest version. So let's try and avoid exploiting any operating system or kernel to get privilege escalation. So let's check out this chkrootkit software. Let's do a search exploit on this chkrootkit. Okay, great. We have a Metasploit module, and we have a text version of the exploit. Let's try to avoid Metasploit. Let's see what is this about. Exploit DB, exploits Linux local 33899.txt. Okay, there is a typo. Put an executable file name update. Okay, so this is running as cron job, so we don't need to run this as UID0 because it's executing as root, the cron job. So all we need to do is to create a file update in the temp directory, and it will be executed as root. So we will effectively get privilege escalation. So that is great. Okay, so what should we create in our temp update file? Let's just keep it simple. Create x86 shell reverse TCP L host will be set to our IP address and L port 443 because we know that that is allowed. Let's call it .1.elf. So these are all just warning, which we can ignore it, it's fine. So once we created our 1.elf binary, we need to transfer it over, and we will set the port to 443 because this will allow our target to download the file on our Python web server because 443 is allowed. So let's quickly download it. Okay, and we are at temp directory. We need to add the executable permission to 1.elf, and then let's change 1.elf to update, and we have created the update file, and let's set up our listener on port 443, and when the cron job triggers, it should give us a reverse shell on this listener as root. So now let's just wait patiently for this to trigger. Okay, we have gotten a callback here, and we are root because as expected the cron job will be executed as root, and since we planted a reverse shell binary here in temp directory, it will be executed as root, and this allow us to get a reverse shell as root. So let's just grab the flag now, and we should be able to complete the challenge. So this is how you can root this box. SickOs 1.2 done. This file looks interesting. Let's see what is this. Okay, so this is the firewall rule that we have encountered while we try to get a reverse shell. You can see that input, so inbound they only allow SSH and 80 and 80. So if we did a bind shell on 80, it could potentially work. And outbound is just the same with 443, which we tested. So usually in real life, port 53 would definitely work, but not in this VM. So yeah, that's all to this video. Please help to like and subscribe if you have enjoyed this video. It will really help the channel out a lot. Thanks.